everybody, this is the conclusion to the video on the lesson finding or estimating the population mean, mu. Alright, this is the real world example. The following data represent the walking stride length of a simple random sample of 10 adult males living in Cambridge, Massachusetts. The results are measured in inches. So I have 10 results. So it does not go ahead and give you the sample mean or the sample standard deviation. You'll have to find those yourself. Alright, and remember I taught y'all how to do that on the calculator in a long time ago in the lessons. Alright, so I've just already stashed my data in my list here. So I'm going to quit that and do one variable statistics. And again, it shows me that my sample mean is 31.16. So I'm going to snag that because the first question asks me determine a point estimate, and we know that the sample mean is the point estimate, so the point estimate would be 31.16 inches. And I'm going to snag that sample standard deviation because we're going to need it. And our sample standard deviation, remember guys, there are two things that are given to me in this list. The S is the sample standard deviation and the sigma is the population. We're not going to use that population standard deviation. We're going to use the sample standard deviation X. And if you have a calculator that does this sort of stuff, it usually discriminates between S and sigma. So make sure you're always going to use the S for this T distribution. Alright, so we're going to take 1.918. So we're going to have 1.918 for our sample standard deviation. Alright, so the next one says, construct and interpret a 96% confidence interval for the mean walking stride of adult males living in Cambridge, Massachusetts. Now, just so that you know, if I were doing the mean walking stride of adult males living in Florence, South Carolina, I could not use this data because this data comes from adult males living in Cambridge. So make sure you're always kind of paying attention to what the question is asking. Alright, so 96% confidence interval. We know we are 96% confident that it is between the lower bound and upper bound, which means I'm allowing myself 4% error, which means that in each tail there would be 2%. Alright, and we have a sample size of 10, so my degrees of freedom would be 10 minus 1, or 9. So I'm going to go to 0.02 degrees of freedom 9. So 0.02 degrees of freedom 9 would give me 2.398. So my T alpha over 2 value is 2.398. We know that our lower bound is our sample mean minus our critical value times the standard deviation over the square root of n. So that's going to be our, let me write it down here, 31.16 minus 2.398 times 1.918 divided by the square root of 10, and that gives me a value of 31.16 minus 2.398 times 1.918 divided by the square root of 10. That gives me 29.71, and we know the upper bound just takes that formula and adds the critical value times the standard deviation over square root of n. So that's going to be 31.16 plus 2.398 times 1.918 divided by the square root of 10. And if I snag that equation or that expression from the above and change that to a plus sign, we get 32.61. So we are 96% confident that the mean walking stride of adult males living in Cambridge, Massachusetts is between 29.71 inches and 32.61 inches. Alright, so I want to take that same problem and I want to change it to a 99% confidence interval, and I want you to see what's going to happen to that. Okay, so just changing that to a 99% confidence interval. We want to be 99% confident. And I want you to kind of notice, in this problem, 96 is here. 99% is a little bit wider than that. So what does that say is going to happen to the confidence interval when we do that? Okay, so 99% is 0.01 for the error. So each tail split evenly would be 0.005. Again, we're going to snag degrees of freedom equals 9. So 0.005 with degrees of freedom 9 gives me a T alpha over 2 value of 3.250. So my T alpha over 2 value is 3.250. And I want you to notice, up here it was 2.398. Down here it is going to be 3.250. So that's going to make that interval a little bit different. Okay, so you have 31.16 minus 3.250 times 1.918 divided by the square root of 10. And that's going to give me 31.16 minus 3.250 times 1.918 divided by the square root of 10. That gives me 29.19. And the upper bound is going to be 31.16 plus 3.250. Oops, square root of 10 up there. Times 1.918 divided by the square root of 10. So I'm going to snag this. I'm going to change this to a plus sign. And I get 33.13. So if I'm looking at that point estimate of 31.16, it is here. Alright, so if I'm putting a confidence interval around it, and it's only a 96% confidence, we've got 29.71 to 32.61. So that somewhere here. 29.71 to 32.61. Now, the larger confidence level, 99%, kind of says it's going to go back, and this is 29.19, 33.13, somewhere outside of that. Okay, so from here to here is my 96% confidence, and from here to here is my 99% confidence. So the more confident you want to be, then you'll have the larger interval. Then the larger the interval. Okay. And that is how you find the confidence interval for a estimation of the population mean mu. Finish up the video finish up the lesson in the next video. Thanks, guys.